Fine. The topic is switching. We should have to know the switch functions. Before that, we'll discuss switch functions. Basically, switch is a layer 2 device. It means it's a data link device, which is a data link layer device. Apart from that, we have a multi-layer switches also. For that, those are the uh, layer 3 devices, but now we have a concept here, switch, that is L2 switch, that is data link layer device. It is an intelligent device. Basically, switch is an intelligent device because it is maintain the MAC address table. So we have earlier hub devices. The hub devices, it's not a intelligent device, it's layer 1 device. It means physical layer device. So the hub act as like switchboard, like its extension box. Just whichever the information received, that information only they'll send. They'll not they will not do any changes. So hub is like physical layer device, but here data link device is switch, and it will be maintain the physical address, means MAC address table. It is used broadcast and unicast. So switch, what it will be do, basically broadcast the information, whichever the information switch got, what it will be do, it will be sent to the every device. That is called broadcast information. Means whichever the information switch will got, it will send to all the knowing devices. If switch got the information, means how many connected ports are there, it will be sent to all the ports. And whenever the will do the whenever the switch is giving reply, once MAC address table established in switch, then it will be do the unicast, one-to-one communication. So whenever the MAC table is not installed in switching, first of all, it will be broadcast the information. After then, once it is maintained the MAC table, that time it will be do the broadcast. I'll explain step by step that process. And it work the fixed bandwidth, and whichever bandwidth we are giving, it won't change. Whichever the fast Ethernet having the bandwidth like 100 Mbps, and Ethernet having the bandwidth is 10 Mbps, whichever the bandwidth switch having, it will be work based on that bandwidth only. And it has one broadcast domain by default. It means by default it having the only one broadcast domain. So here we have a switch L2 device. It's a switch one, and the switch is connected like here multiple ports, multiple end user, multiple host. The switch is connected here multiple host. Host, it means PC or server or anything. You can assume host means. So mute yourself, guys. If you have any queries, ask. Otherwise, mute yourself. So whenever the switch is broadcasting information, this PC1 originated some frame packet, some frame. Two, he wants to communicate this PC5. This PC1 wants to communicate PC5. In between, we have 2, 3, 4. But whenever the frame originated, so in this time, that switch don't have any MAC table. So it will be send the packet. Whenever the receive the switch packet, it will broadcast the information to everyone. Broadcast to everyone. All the port, the information will get. In this time, the replying time, the PC1 only replying. That is unicast. and whenever the sending packet, that is broadcast. So every PC that information will get. So how will break this broadcast? We'll discuss those things also. But before that, this is broadcast and it one replying part packet is unicast. And one broadcast domain by default. Here only one broadcast happen in this switch. Entire switch only one broadcast by default. If you want to change, we can give the multiple broadcast also with the help of VLAN. With the help of VLAN, we can create multiple broadcast domains also. We'll discuss those things. But now by default, only one broadcast domain. And here a number of collision domain depending upon the number of ports. It means this PC also giving reply, this PC also giving reply, and this PC also giving reply. That time only this PC will receive this information also for this. So here number of collision also. Collision means dashing. It means sending at a time and receiving. Both at a time it will be, that is collision. So here we have number of collision. Number of collision domains happen depending on how many ports are available, how many ports are connected to host, that many collision domain will be happen. Send and receive at a time. It maintain the MAC address table. A switch will maintain the MAC address table, MAC or you can say CAM. Fine. Any doubts up to here? Guys, any doubt?
No.
Fine. Or CAM table. Broadcast domain and switch bases worked on ARP table. See, resolution protocol. ARP, it means address resolution protocol. ARP protocol helps the switch to resolve the IP address in the respective MAC address. It is inbuilt protocol in TCP IP model. Means knowing IP address to unknown MAC address, it will be resolved. It will be it will be find out the knowing IP address. For example, if I want to communicate PC1 to PC5, so the PC1 IP address here 192.168.10.1 and /24 192.168.10.1/24 and 192.168.10.2. Sorry, 5 of this PC. So these all PCs are within a network, and you can assume the MAC address of this is A, and this MAC address is EE. So here we know the IP address. So we'll try to ping with the help of ping command, ping packet internet buffer. We'll trace out the reachability it is there or not. It will be if in between reachability is there, with the help of will ping, will find out the device. So will ping IP address whenever originating ping 192.168.10.5 from which PC? PC1. PC1 to be try to ping. Then the time the this MAC address we don't know. So first it will be find out the MAC address with the help of ARP, address resolution protocol. With the help of knowing IP address to MAC address, it will be find out. And it is inbuilt protocol in TCP IP model and OSPF, OSA model. We'll discuss more about it. But whenever you are discussing packet flow from one PC to other PC, so first it will be send one packet to this behind ICMP protocol will work, Internet Control Message Protocol. So what it will be do? First it will be send one packet request, ICMP request, and it will be give the ICMP reply. It will be give the reply. First request, then it will be give the reply. The request is here, it will be originate. So behind, whenever you are pinging, try to ping, behind the ping protocol, ICMP will work. Now we'll discuss the packet flow, each and a step-by-step process. Because switch what it is doing, we should have to know. If we don't know behind the switch what it will be happen, so we cannot understand the future topics. So first of all, we'll do the, with the help of ping, we'll find out the packet flow of PC1 to PC2. So first of all, whenever the PC1 originated one traffic are trying to ping, so here the destination first source and source IP. First, we should have to know source IP. Then destination IP and source MAC and destination MAC. In so now, what will happen? We'll discuss here. First, PC1 trying to ping. PC1 information is there. And so PC1 try to communicate PC5. So PC1 IP address, source IP address is here 192.168.10.1 and destination IP address is 192.168.10.5. Now source MAC is same, whichever they have AA, but Whenever the destination MAC is unknown, whenever the destination MAC is unknown, then it will be broadcast the information. So that is a broadcast domain. That is a broadcast domain. In this switch, for example, this switch, PC1 wants to communicate directly PC2. PC1 wants to communicate PC5. Now, only two PCs are there. Directly, it will be broadcast the information. But in this case, we have different PCs also. So that time it will be sent to everyone, broadcast the information. So the broadcast MAC address is here FFFF 48 bit. After E, we are not getting the E. F after E, I have taken the EE MAC address randomly. But here FF means by default it is doing the broadcast. Whenever the IP addresses range will be start from like sorry, MAC address range is start from is like 112, like it's a MAC address AC ED is it's a hexadecimal format, means likewise the hexadecimal format MAC address will be happen in real devices. So FFFF means it's totally broadcast the information. After this, no, it will be entire how many connected ports are available. It will be sent those many ports. FF means. So now it is broadcasting the information. Whose switch is broadcasting the information? So we are trying to ping PC5. So who will give the reply in this time? So PC5 will give the reply because we know the IP address. Switch also know the IP address. So switch this port is give the reply to this PC. That time now giving the reply. This is a request and this one is a reply. PC5. This is a PC5 information. Now check here PC. Now source IP address is PC5 source IP address 192.168.10.5. 10.5. Now destination IP address is now PC1 is destination IP address. Now because unicast it is doing. It's a unicast packet 192.168.10.1. Now we know this PC now having this MAC address. Now because this is sending through this port PC. Now PC5 is giving her MAC address to this switch. Now switch is maintain this. The MAC address is EE. Now earlier, whenever the switch one is initiated some packet, that time only switch one knows the switch knows the PC1 MAC address is AA. So directly it will be sent. You are the originated traffic. So it will be give the reply. Now this table will maintain up to 300 seconds. It means now switch is maintain this table up to 300 seconds means 5 minutes. Switch will maintain if in between also originated some traffic, same time will be repeated, same thing. This is the packet flow of switching. This is the entire process. What we did, just go through this process, switching process, you can understood. Which sends broadcast flood frame out of all the ports if it is received a frame with the destination MAC address is not present in the MAC address table of switch send with destination address FFF. So in this switch don't have this MAC address, then it will be originated packet like broadcast. It will be do the broadcast the packet to entire switches. If the destination MAC address is present, then it will be send only the specific port of per MAC table. So that is it. If the switch have present in MAC address this MAC table, now whenever it will be now switch is maintain this MAC table, that time it will be do the unicast only. So update of MAC table happen based on the source address of the frames. It will be update based on the source address, and it will be maintained 300 second 5 minutes of traffic. In MAC table time is 5 minutes. This is all about switch. Any doubts? And here mainly we have two types of switches. Here we have two types of switches, manageable switch and unmanageable switch. Here we have two types of switches. Unmanageable switches, these switches are just plug and play. It will be send and receive the information. No configuration and verification can be done. It will be received, whatever it will be received, that information only it will be sent. There is no console port and we cannot access the device with the help of console port. Console port, it is like it is like management port. With the help of console port, we can enter that switch, and whichever the configuration is required, we can do. In unmanageable switches, it's like hub only. This kind of switches, like we can say it's a hub only. We cannot change anything. And manageable switches, these switches are also plug and play, and whatever information it is received, that only it will be sent. It has console port and CLI modem, command line interface. CLI, command line interface. With the help of command line interface, we can changes. If I want to change any VLAN, if I want to change any IP, if I want to give any management IP address, if I want to give a trunk port, if I want to change STP configuration, trunk port fast, BPDU guards, whichever information STP ports I can change. We can verify, modify configuration, can implement the test some advanced switches, technologies like VLAN trunking. Those things only we can change here in manageable switches. What will configure in mainly in L2? VLANs, trunking, and STP in L2. These are the L2 protocols. We can configure, we can change it in manageable switches. Okay, now we'll discuss Cisco hierarchical network design. Network design, how it will be happen. How it will be happen. Hierarchical network design model involves dividing the network into discrete layer. Each layer provides specific functions that define its role within the overall network. The typical hierarchical design model is broken up in three layers: access layer, distribution layer, and core layer. Access layer, distribution layer, and core layer. So first of all, we should have to know how it will be happen in hierarchical design. show you in diagram, it can easily understand. See, it's a these all end users. End users means laptop, PC, printer, home network, home office, or any teleworker means you are using some mobiles or tabs, those things, and printer, wireless devices like laptop. These all are the host, and after then it's an access layer. In access layer, we have access switches, L2 switches. These all are L2 switches. And apart from that, in distribution layer, we have L3 switches or L2 switches. Again, it's a core layer. We have core switches in this core layer. So you can check whenever you are connecting switch to switch, then crossover cable and switch to switch. And if you are connecting switch to any different device, if you are connecting same device, router to router, switch to switch, or PC to PC, any device to any device. So any device to same device to same device, you are connecting, then crossover. And if you are connecting different device to different device, like router to switch, switch to PC, or PC to some router, that time you'll use like straight through cable. Okay, this is the access points, and these all are end user. This is all are access switches, and these all are core distribution switches and core switches. Before that, which we'll discuss which series switches will use at each layer. If you know these things, you can understand very well which series of switches will use and what it will be do. Series you should have to know. Cisco divided switches into three layer. Access layer switches are like 1900 series and 2900 series will use as a L2 switches, that is here. Access switches. These are the access switches, access layer switches. And distribution layer switches here, series are 35. It's catalyst switches, again, catalyst switches. And 3550 and 3560. These series switches will use mostly at distribution layer, and core layer will use advanced layer switches, and not even though this only, and 9300 also will use 9300 or catalyst 9200 also will use. And this multi-layer and distribution and core switches like L3 switches or multi-layer MLS switches. This is a three-tier architecture, actually. Architecture. Three-tier architecture. Guys, you should have to know in each layer what it will be happen. First, we'll discuss here at access layer switches. There we have multiple switches. This access switches multiple. If you have one branch in that branch, sorry, in one campus, you are working in one campus area. In that campus area, you can see like multiple different departments. So this is a account department, you can also, and you can sales department, is this one HR, or this one so IT department, IT department, and some business department. some business development department, some admin department. You can see here multiple different devices, different what we say, we have like different account, they have multiple departments. So each department they have multiple users. They have multiple users. These all are PCs. Multiple users. They are using some laptop, some with this access switches only connected to again access points. Access points is AP. Access point in your home also we are using access point. Access point nothing but again Wi-Fi device. Wi-Fi. Okay. And this Wi-Fi is connected to some laptop, phones. This is your mobile phone, or you are using one laptop. Okay, these all are access points are connected to access switches, and this access switches connected to distribution switches. Likewise, in this access switches, we'll use access ports. Access ports. In this access port, will carry the only one VLAN information. So this VLAN is 10, and this VLAN is 20, and in this VLAN is 30. Like access port will be carry the single VLAN. So here we'll create access ports and multiple users here. If you have 100 users, we'll advertise this 100 users will connect this switch. Access switch to distribution switch, and this also distribution switch. In between, what will do? Access port. This is the access port will create. Otherwise, if you are configuring here multiple VLANs also, otherwise you are configuring here multiple VLANs, then you'll use trunk port also. In between two switches, will configure trunk port. That is depending on scenarios. That is depending on scenarios. If you are configuring as a multiple VLANs in this access switch, will configure in between trunk in this port as a access port. This port as a end user will connect as a access port. Okay, in between will configure trunk port. Trunk port will configure trunk port in between. And this switch is connected to distribution switch. Distribution switch to and core switch. The core switch is having redundancy. Here we'll use HSRP, VRRP, this kind of protocols, HSRP and VRRP. These are the redundancy protocol. One switch went down, then other switch will be work. Okay, this kind of scenario it will be work. And here we'll create ACL. In between we'll create the ACLs, access control list. Based on policies will deny or some traffic we should have to, we can deny or permit. Okay, why we need a distribution layer? If you want a two-tier also, it is possible. Okay, you can give the two-tier architecture also directly connect to those things. If when the time you don't have multiple user requirement, because this core layer switch is having high capability. That is the reason we'll do here routing also routing also will do here in core switches in between, because multiple network we are advertising here. We have this is the different network, and this one is the different network, and this one is a different network. So we are advertising multiple routers, so in between we'll do the routing also. These core switches are connected to ISP. In between, we'll use the firewall also. What we'll do with the help of firewall? We can monitor the end user information, what they are using. We have different types of Palo Alto firewall, Fortinet firewall. These are the vendor and ASA firewall, Firepower firewall. This ASA and Firepower are the Cisco proprietary Cisco firewalls. What we'll do, we will monitor the traffic, the end users, and will create the policies. If we will deny or permit some traffic through if he's trying to access one Facebook server, just will deny here. If you don't want to allow, if this end user with the help of IP address will deny, simply he cannot access this Facebook server. So whenever we did deny policy, we create the policy. That time he cannot access the this Facebook application. This is all about three-tier architecture. What will configuring here? Basically, in this 1900, 2900 switches, these are the manageable switches actually, and will create here VLANs based on our requirement. If there we have this switch also connected like multiple departments also, you can assume this is in first floor and second floor and third floor and fourth floor, fifth floor, sixth floor. Different floors we have different access switches. That time at a one floor only we have only one access point. Only one access. This switch is connected to one access point, another access point, two, three access point. That is depending on distance of meters. How much distance will put likewise. How many access point will require. Each access point will use up to 24 users. Up to 24 users we can use for each access point. So if we have multiple users, then we need a multiple access points. So we'll create based on the VLANs, and we'll do in between trunk. And here also we can create the ACL policies for security reasons. Here also we can create the ACL policies. ACL policy is nothing but to deny or permit the traffic. Standard ACL and extended ACL, we'll discuss those things. But here we'll create in between. This is the hierarchical design. And one more thing, at routing, where we are applying in between distribution to core switch or core switch to ISP, because we should have to, if I want to communicate at different location, different branch I have, that time I need in between my private IP to my private IP, my private branch to my private branch. If I want to communicate in between, I should have to do routing. And this is a series of switches. Guys, understood? If you have any questions, still what we discussed, ask me. Otherwise, we'll move to the next topic. Understanding or not? Till what we discussed, understood? Everything, everyone. Deep, Dilip, Soumya, what is the difference between unmanageable and manageable switches? Jagadish, what is the difference between manageable and unmanageable switches?